So in theory, the Wi-Fi code is still there. Okay, so I'm going to put this up while I talk for a second, because Jim is more prepared than me, so he had stuff ready to go. But materials for this next 40 minutes will be at this QR code and that link. And then also because Rebecca said we should answer questions and talk about grad school and stuff, pretend there was like a big orange block eye here. And then if you're interested in graduate school and statistics, data science, computer science, any of those things, and would like to be in the middle of a cornfield, strike that cornfield and soybeans, ask me questions about University of Illinois and all the things we're doing there. I'm realizing I need to talk here because this is where the microphone is. Sorry, I have a tendency to wander. Right. I'm going to try to leave this up simultaneously while I start talking about some other stuff. So, as Ron mentioned, Jim authored Analyzing Baseball Data with R, and we're going to do exactly that right now, analyze baseball data with R. Hopefully, people are interested in baseball. I know football is the popular sport. How many people watch the World Series? Okay, good. And just I did this in a way that hopefully everyone will get something out of this, but how many people are familiar with R programming? How many people have used StatCast data before? Okay, some. Okay, good. So we'll have a good mix of things. Okay, so if you were able to go here, it would have taken you here, which if you need to find this later, you just Google my name and you'll end up on my website, you'll end up on my GitHub, and it's there somewhere. It's a repo named CMSAC 2024. And so what I want to do today is recreate some visualizations and analysis that is on the website Baseball Savant. How many people are familiar with this? Okay, so if you're not familiar with this, baseball has a strong tradition of analytics, and these days a lot of it, you see public facing a lot more. Depending on the broadcast these days, they have a lot of analytics broadcasts, but this website has a lot more. And given that the World Series just happened, I'm going to, for the next 40 minutes, talk about Garrett Cole. I don't know how people feel about that. I mean, he pitched a good game. No comment on defense. We're not going to analyze defense today. And so what I wanted to do is, as a way to introduce StatCast data, try to reproduce various things on this page. In order, I'm scrolling way to the bottom here. I first want to try to reproduce this graphic here. Then after that, I want to reproduce this set of graphics here. And then lastly, time permitting, and if not, I'll post all these things, reproduce this graphic here about movement profile. Okay, so spoiler alert, all these things are already done. And if you're on this page here, in the top right here, this link will take you to a rendered document that's going to more or less have everything that we attempt to do here. But I've sort of written it in a way where we're going to start from almost nothing and then build up to those things. Feel free to interrupt me, ask questions, et cetera, et cetera. I have a tendency to just keep rambling, and then I become like half blind that I don't see that you have your hand raised. So if you need my attention, just say, hey, Dave, and that'll potentially work better. Okay, so I'm going to go back here. Sorry, I need to close some things so I'm not all over the place. Wi-Fi code one last time if anyone needs it. Okay. So we need, I'm going to get rid of this too. We need data because this is all downstream of the data itself. People have already summarized it, analyzed it, posted it, made it look nice. So how do you get baseball data? So along the way, we're going to need these packages, and I'll come back to that. But at the end of the day, there's this thing called StatCast. If you've watched a baseball broadcast, you've probably maybe heard about it, although you've probably more so heard about how Google AI Cloud powers all this. But anyway, but so on the StatCast, or on the Savant website, they have this thing called StatCast Search, and it has all these drop downs and things where you can select what players you want, what information you want, do all sort of filtering and all that good stuff. And if you search, it'll populate your results, and you could download them as a CSV. That's one thing you could do, although I wouldn't necessarily recommend that if you're at all used to using R and those sorts of things. So there are a number of ways to access this data in R. I mean, you could just write API request yourself, but I'm going to sort of recommend that if you're interested in this kind of thing, I linked to this package from Scott Powers at Rice. It essentially is a nice package that allows you to access this data. I will make a request though, please don't everyone do that right now. A, it'll take too long. B, I provided the data. And I think if we all started querying seasons worth of MLB data together, it might block the CMU IPs, and we don't want to do that. So pretend I didn't show you this until later and then have fun. Okay, so, and then along the way, in terms of R that we're going to use, we're going to stick to basics. We're going to use just regular old R, a little bit of dplyr, a little bit of ggplot2, and a couple extensions of ggplot2 just to get my bearings. How many people have used ggplot2 before? Okay, pretty good. So depending where you are in R proficiency, ggplot proficiency, my hopes are if you're new to this, hopefully you see that the power of these things and you start to learn them. If you're experts of this, hopefully you pick up a tip or trick along the way. I've linked the documentation for dplyr and ggplot2. The things that people usually like on these websites are the so-called, if it loads, cheat sheets that allow you to, learn these things pretty quickly. Okay, enough of that. So all the code I'm gonna go through is either on this webpage, on this GitHub repo, however you want to access it. I'm going to do the maybe scary thing and try to code some of it live in front of you, and you can follow along and ask me questions, etc. I will have some questions for you as well. So please don't hesitate to answer them. Real quickly. So this code here should, in theory, install everything you need if it's not installed. So just run that. If you run into errors, the first thing you should do is just try it again. And then if you keep running into errors, maybe let me know. We can try to work through them, and this will load them. And this, so rather than downloading the data directly from MLB, we're just going to use a subset that I created and will be read directly off the web. So let's start doing that. And in the repo, I've provided this as a so-called Quarto document. How many people are familiar with Quarto? How many people are familiar with R Markdown? Okay, you know Quarto too. It's fine. You'll see it's the same thing. I often, for live coding, like to just code in a script, and all we're going to be doing is making tables and graphics. So sometimes that extra stuff feels like it gets in the way for me. So I'm just going to do that here. But so basically, what I've done, I've copied, the basics from that website you saw there, and I'm just going to start running things, and we can talk about them. Okay, so if I load the data, it initially looks like this. Can I get rid of this somehow? Good enough. Okay, and you can't fully see all the data, but if you pull up the nice data viewer in our studio, you can see that, there's all this data. What is this data? Each row is every pitch that Garrett Cole threw in 2024. So if I'm reading this correctly, he threw about 1,500 pitches and change. And then there's a bunch of information about each pitch. In the interest of time, I'm not going to go through what each of these 96 columns are. If you're interested in that, there are two places I will send you. One is to the documentation from Savant, but actually I'm going to probably suggest instead Appendix C from Jim's book, Analyzing Baseball Data with R, where they sort of give a little bit more information and kind of group some of the variables together so you can understand how they relate to each other. But in the interest of time, what I'm going to do is subset the data to some variables that we actually care about, and I'll do it in a way where you can actually see them. I'm going to do it in a way where you can actually see them. Right. Okay. So we're interested in pitching, and so what we have here, it's just 10 rows, but you can see we have the pitch type and the pitch name. This will forever confuse me about baseball analytics, is they refuse to use pitch name, and everyone uses pitch type, but they encode the same information. But if you're new to baseball, you probably don't know what FF is, but it's a four-seam fastball. It's fine. It's all the same. And then we have just a little bit, there's more, but we're just going to look at a few key variables. So one is the speed, one is how much the ball spins, and then where the ball crosses sort of the plane in this, if I'm the catcher, where it crosses sort of in these directions, and then how much the ball moves in those same two axes as it travels from the pitcher to the catcher. Okay, so actually, I'm going to cheat a little bit more in the interest of time and do this real quick. So one thing you might want to know right away is how often does someone throw the various pitches they have, and what are some basic statistics of them? Yeah.
Let's do it all
Stand here.
real quick.
Okay. I moved too much. Should I mute this one?
Yeah, just push the button.
Testing some more. Thank you. Okay. Now I could like stand over here. Okay. Anyway, yeah, so you're saying these will be about where the ball crosses the plate. These will be about how the ball moves as it gets to the plate. And what I'm doing here is two things. Just quickly summarizing that, the four-seam fastball is, like a lot of pitchers, his most common pitch. And then he has 5 other pitches. He doesn't throw the sinker all that much. And then, sort of as expected, the four-seam fastball is the fastest. That knuckle, the knuckle curve has the most spin. Sort of not all that unexpected. For those of you that use things like dplyr a lot, there's a little trick I'm using here that a former student taught me. When you're piping things like this, sometimes you'll want to be piping and saving the result in a new variable, but you'll also want to be like sort of working on the things in the pipe and checking it along the way. So by using the curly braces here, depending on where your cursor is, you get a different functionality. So if I'm inside the braces and I run it, it just shows me the output because it's just running what's inside the braces. But if my cursor is on one of the lines with the braces, it runs that and stores it and doesn't show you the output. I find that to be incredibly useful. Shout out to my former student, Jack Banks, who's actually working for the Yankees now. So that's, I guess, relevant. Yeah, I don't know. That's a little, I use that every day almost. That's a fun little trick. Okay, so what are we actually going to do? We want to reproduce this graphic. And it's on the page itself, so if the zoom here isn't good, again, it's sort of towards the bottom. So what we're looking at here is, for each pitch type, what is the distribution of the speed at which he throws these pitches? So we saw earlier the average of the fastball is like 95 miles an hour, but there's a distribution around that, and we might want to know about that. So what I have in this document is two things. The thing we're going to try to do, and then some starter code that will do sort of the most obvious thing with ggplot2, but clearly will not get us all the way there. So what does that look like? It looks like this. Okay. So this obviously isn't what we're trying to do. This might be like a really obvious question, but like, does anyone want to tell me something that's wrong here we need to fix? If you want, you can suggest the first thing we fix and then see if I can do it on the fly. That could be fun. Not for me. Yes?
I think like right now, like I think you're having an issue. Like I think like you're not separating out like all the different pitches. Right now, I think you're just like combining everything. I think you're just I think like this, you're just combining everything together and not creating each of the individual pitches as like a separate action.
Exactly. So the comment was, I'll repeat it for the microphone and Zoom. This is just an estimate of the density across every pitch he throws, irrespective of pitch type. So that's one thing we need to do for sure. Does anyone see anything else? I'll actually flip back here so we can see things together. One of them might be subtle. In the back. Oh, that's kind of the same comment. Yeah, it's 6. 2 of them are kind of hard to see there, but yeah, exactly. Yeah. Yeah. So I mean, yeah. So correct. So we're sort of talking about two different things here too. Some things are just like statistically what do we need to do? Like we want to look at the distribution of each pitch type rather than just all together. Then there's visual things we need to do. Like this is just the curve, but visually they're filled there. Okay. So that's a lot of what we need to do, right? Okay. So let's start to try to do some of that. And I think if we do something like this, that should solve maybe both of these problems together. And this is what we get. And maybe I'll do that. Does this look correct?
I think the distribution looks too narrow in that one. And in the previous one that you said there's a subtle difference between the imaging and the others that we first looked at. I think the distribution is too narrow. There's more variance in speed of pitches.
Yeah, you're on the right track. It's a weird, subtle thing. Flipping back there, flipping back there. Does anyone want to elaborate? Yeah, go ahead.
I feel like there's also an issue with with the y-axis variable, for the actual example, they're saying frequency of speed in terms of percentage, and right now we're just saying we're showing that like a density.
Yeah. So what we have here that we've created so far is a density estimate for the velocity of each pitch type. Correct me if I'm wrong, but each of these should integrate into one. But they're doing something different here. They're not plotting density, they're plotting something called frequency by speed, so it's a little bit different. So yeah, exactly, more or less. This is where it's gonna, we'll solve that in a second, but does anyone want to make any quick visual comments too? Way in the back. Yeah, so right now, some of these distributions are sort of hidden behind others. Actually, let's fix that real quick. Does anyone want to shout out another one while we're doing that? Any other visual things if we were being like really nitpicky? Okay, well, I'll suggest one because this is one that bothers me. I don't like the default ggplot theme. Maybe it's just me. I think that looks closer. Actually, I think it might even be better to do this to truly replicate it, but we're going to want to see that axis in a bit, so there's that. Okay, so there's this issue where, as was stated, these are too narrow. Their actual densities, they're plotting something else. Does anyone have any sort of suggestion what we should do here? Is that a hand? Yeah, go ahead. Oh, we did that. It's just still pretty rough because they're so overlapped and there's not much we could do with that. I mean, pick an alpha value you like. I mean, that's actually better. Thank you. But how do we like the heights and the widths of these things? There.
You need to map something to y in your aesthetics, so you have like the count of pitch per type and then over the total number of rows in the data set.
Bonus points if you can tell me how to do that. Yes, exactly. So this is getting into like a little bit more advanced ggplot, but so right now we're just saying, hey, plot the densities given these x's by pitch type more or less. But we can be more specific about that. We can sort of tell it, well, what should we actually put on the y-axis? So the comment was use after stat, right? And then this is where I'm like, well, my mind's going to go blank here. I don't know what to put here. Does anyone know what I should do? Oh, I don't know why I did that. Look at the documentation. So ggplot is a really nice package, and it's based on geoms. Anytime you don't know how to do something with a geom, you go to the documentation. And the documentation is actually kind of really well organized. So one thing it'll tell you is what are the visual things you can change with the geom, and folks have already told me to change alpha. But there are these statistics and quantities that it's computing under the hood that it's not necessarily showing you. But so for example, within this, it's calculating a count type process. So I think if I do after stat count, as was sort of suggested, we might get a lot closer. Not bad, right? But do we still have problems? I should say at this point, like for analysis purposes, like we're close enough, but if we want to like learn ggplot2 and like there are things here that are different still. I think someone might have suggested it already, but something changed, so I'm curious if, yes?
We just got the raw pitch counts on the y-axis right now.
Mm-hmm.
So is there a way to shift it more?
Sure. So I think we could do something like this. There might even be a better way to do this because it'd be computed internally, but yeah, sure. Better, right? Okay. I'm gonna claim victory and move on because this plot. We can only talk about one plot for so long. But if you're interested in getting it even closer, you can just cheat and do this. And there's some stuff that I did. Yeah, so the tricky part that like I don't want to go through, and I don't think you want me to go through, is like getting the label on the y-axis to be like a whole number and a percent and the same spacing that they have, but that's too much work. And then of course you're gonna label your plot appropriately and everything, and not leave an axis with after stat count divided by n row, etc. on the y-axis. Okay, cool. We got one. All right, so this will be maybe a little more fun and a little more interesting, and just want to be mindful of time. Okay, so this graphic they call the pitch arsenal, and it sort of shows a number of things about in this case, 6 pitches that Cole throws, the four-seamer through the sinker. I just want to point out a couple things because it'll come up. If you kind of notice, these are ordered by the frequency with which he throws them. So the top left is his most frequent pitch, the four-seam fastball. The bottom right is the least frequent pitch that he only threw 12 of, which is the sinker, which is another type of fastball. And then, so basically, it's the rectangle is the strike zone, and then it has these contours for, actually, question mark. Doesn't really say, so we're gonna have some fun trying to figure that out. And then if you actually look at this on the live website, this is a screenshot, the balls are rotating according to the axis about which they spin. We're not gonna do that. I don't have the ability to do that in live time, but we'll try to do everything else. So there's actually an interesting question that comes up along the way here, which is, what is the strike zone? I could make a joke about umpires, but I won't. Yeah, so I'm not the first person to ask that question, and then there's a theme here. If you want the answer to well, there's a lot of places it's answered, but within Analyzing Baseball Data with R, there is a section called Where is the Strike Zone? But so in some sense, it's the outer edge of the plate plus the ball only just has to touch it, so it could be on the edge. And then there's something we're going to do arbitrarily along the way here, which is the top and bottom of the strike zone are different for each batter. And for each pitch in the data, there are actually columns that indicate the top and bottom of the strike zone for the current batter that the pitch is being thrown to. But because we're looking across all 1,500 pitches, we're just going to sort of arbitrarily set one. So Aaron Judge would be very mad at us. Altuve would be very mad at us. But we keep going anyway. So just a few things that are happening here. So this is some starter code that's just kind of boring that I don't want to try to do live. The first one actually is just to produce that line of code there that gives me a vector with the pitch types because what I'm doing here is I'm changing the pitch type variable to be a factor. But specifically a factor ordered by the frequency that the pitches happen. We'll use this in a second to order the graphics appropriately. But the top line there, what I'm doing is the sort of usual dplyr thing, like I'm pulling out a single variable as a vector. Actually, we can just look at this. This is another little trick that I find myself using that I sometimes wish someone would have showed me years ago. So I'm getting a vector back, and this is how R prints a vector. In my actual daily life, I've been using Python a lot, and often when like NumPy prints an array, it kind of gives you the code to produce the array. But this is not the code to produce that vector. And I could certainly store it and then pass that around, but sometimes you come across these vectors that it's a one-time thing, and it wouldn't hurt to hard code it somewhere else. So there's this really nifty function called dput, and I actually have no idea what that stands for. But what it does is it gives you the code to produce the vector that you're interested in, so I can then use that later. For example, that's how I produced this right here to get that vector ordered the way I did, and I didn't have to type it out or store it or anything like that. Okay. And then this code, which we're not going to create, this is just to create a strike zone sort of that you can use within ggplot2. So we'll just kind of pretend that we made that together and then use it. Okay, and then this code does some stuff, and we can talk about what it does, because it doesn't do anything that great. Okay, so if we kind of have it so that the code is visible at the same time. So what I'm doing here is I'm making a plot where the x-axis is where in the x-plane the pitch crosses the strike zone, well, the plane that includes the strike zone. The y-axis is z. I always forget if this is from the pitcher's or catcher's perspective, but we can figure that out. And then the strike zone is sort of overlaid over a bunch of points. Can anyone tell me one of the many things wrong with this?
You need to rotate it.
This way? Wait, you talking about flipping it horizontally, or do you want me to actually rotate it 90?
Let's see, yeah.
So it's X, Y, Z. Yeah, pretty sure.
Yeah.
I sometimes forget about that one too. You could, and it's also arbitrary if you wanted to flip it horizontally or not. It's just if it's the catcher's perspective or the pitcher's perspective. I believe this is from the catcher's perspective. We could double check that though. But I mean, there's other really obvious things wrong here, right?
You need to scale your x y axis.
Okay, I'm glad you went here first. So right now, for example, if I rearrange this viewer window, it's going to completely change the aspect of everything, right? And thankfully, ggplot really helps us with this one. And there's a shortcut for this where you set chord equal, and now no matter what I do to this viewer window, it's always going to have the X and Z be the same spacing between tick lines there, because these are representing feet, right? Feet? Yeah, so we want them to be represented the same way, yeah. Other things? Yeah. Yeah, so this is one plot. We want 6, right? So to do that, the suggestion was to facet, well, you said wrap, so let's do that. You could do it various ways, and then I think you do this. Cool. I mean, we're doing pretty good. I should mention that on the Savant website, there are, where are we? Not there. Here. There's actually some interactivity here that I haven't shown yet, which is, so by default, it shows you these contours, but there's this drop down here where you can overlay the pitches themselves. You can show only the pitches. So in some sense, we're about here right now, more or less. So there's that. Homework for anyone that's thinking like, oh, all this is too easy, I've seen this before. Okay, so your job is to then take Shiny and reproduce this whole page with all the interactivity and given any picture. That's your homework for tonight. Okay, cool. So we're here, this is here. I'll suggest one that'll help us out visually a little bit. So these are just kind of floating in a void without any sort of axis marks or anything like that. So we can actually accomplish that one pretty quickly too. Theme void. We're doing pretty good. Actually, I don't love that. We'll keep it there. But you could do something like that. I just don't like the way it puts the labels on all of them. But so, not terrible. So now the question is, what if we wanted to do these contour regions that they're doing? I don't have a good solution here. The solution here is to use, I'm going to use this GG density package. So if you do a little searching, be like, hey, how do I plot 2D contours like this? Because what we're looking, because what I assume they're doing is they're computing like a some sort of mixture or kernel density or something, and then finding the highest density regions. Thankfully, this package gives us, and I'm going to cheat a little bit because I don't use this all the time, and I wrote some code already, so no one watch me as I do this. You didn't see that? Okay, let's add that. And so something we should think about a little bit here is the order in which we're doing things. We'll just do this for now. Pretend you didn't see that. Let's see if that works. Right, okay, so this looks kind of terrible because for a number of reasons. One is that I've plotted the contours after the points. We're doing them at the same time. When you cheat and look at the solution, you'll see that I just gave up and made two distinct plots rather than doing one on top of the other. But so let's actually focus on the contours because that's what it shows by default. So let's get rid of the points, which we'll just temporarily comment out. And so, and actually let's set this to no alpha for the moment, and let's see what that does. Okay, so this looks terrible. Maybe you can't see it here. I can kind of see it on my screen. There's kind of lines happening here, and there's kind of stuff happening there, but so we need to map something to that and do some color stuff with it. Right, so, I'm gonna cheat. I'm allowed, okay? So what I actually ended up doing, actually we'll just talk through this. Well, let's copy it and put it in there, run it, do that kind of stuff. Okay, so because I wanna make two different plots, and there are a bunch of different ways you could do this. So what I'm doing is first I'm making a plot that has everything that's gonna be contained in both. So there's gonna be the strike zone, I'm setting up the limits and everything, I'm setting the labels to try to get everything as close as possible. So what I mean is I'm producing just the blank field upon which I'm gonna land everything, and then I'll save it. I'm using that little trick again, but in ggplot. So here is the, as best I can match, and I'd love to, if someone figures out what regions they're plotting and what bandwidth they're using in their estimation, I'd love to know. But here was me sort of guessing and checking a bunch. But one thing that I think that we have now matched them pretty well on is the coloring here. And so are there any visualization experts that want to explain like the difference between, so they're going from blue to neutral to red. Is there a term anyone wants to throw out for that?
Heat map?
It's a sort of heat map, sure. Say it again? Actually, let's do this. Has anyone, these scale fill brewers, has anyone used these functions before? I keep thinking my console's gonna be down there, but it's not. So if you look, where is it? Yeah, so there are these different types of sort of, they call them color palette executors, right? So sequential will kind of do what they say. For example, the blues will go from a light blue to a dark blue. Is that what we want here? I don't know, I'm just copying them. Qualitative, those will be sort of different colors that like next to each other look very different. What we wanted was something that's diverging, so it goes from like a really cool tone to a neutral to a hot, in this case, red. I'm not a visualization expert, but there's like color theory behind all of this. But if you're interested in that kind of stuff, I think these websites that are listed here, like Color Brewer 2, will talk about all this stuff and why for different types of variables and different types of plots, you want to use different types of palettes. But I'm not a visualization expert. I just pretend sometimes. But yeah, so, and then we could simply just add the points on top of that, but I frankly couldn't find a satisfying way to do that. So I just made a separate plot with these points. I'll maybe give another homework assignment to folks that are already experts at this. So the problem that I had, because I wanted to try to match them as closely as possible, so let me show you the problem. So contours, fine, we can kind of do that. This is going to be super nitpicky. But when we overlay the pitches, maybe if I zoom in a little bit, so if you look at what they're doing here, they are putting the points on the plot, so geom point, fine. But then they're doing a point with a fill color and then like a black circle around it, which I like because it's easier to see against the contours when you put on top of it. But here's the problem I ran into, and again, like 3 fake gold stars to whoever tells me how to fix this. If you try to put them on the same plot, the interiors of the contours will be defined by a fill. The interior of the points will be defined by a fill. And then because we're using this scale fill brewer, it'll try to apply that to both the contours and the points, and it'll basically break the points. So if anyone comes up with a solve for this, I'd be curious. You could think, oh, just use color for the points, but color for the points, depending on the point type you're using, will be the outside of it. Or if it's the whole point, then you can't put a circle around it. Yes?
This is a question. I don't have the answer.
Okay, I was gonna be so happy if you had the answer. I'm happy with the question too, though.
Yeah, so maybe it's a bad question. But
No such thing.
The points.
And if there was, I would decide, not you.
So I'm just wondering, like, why doesn't alpha of less than 0 just roughly look like the density plot?
Alpha less than 0.
Like, why don't these plots approximate that, deeper color? Like, it wouldn't be diverging, but like, why aren't we seeing deeper reds and like cleaner reds?
Oh, sorry, are you asking, sorry, the problem is that right now there's no alpha on these points, I think. Because right now, because I think if I do this, does that help a little bit? Yeah, because right now they weren't blending in with each other, so they weren't making it stronger where the red was. I think that's what you're asking. Yeah, no, that was me making perhaps a poor choice. But I don't think they're doing alpha blending, but someone could check me on that. There was a hand in the back. Yeah.
Oh, I have an idea about
I'd love to hear it.
plotting a bit. So maybe try 2 geometries, one with a solid dot.
Oh, I love where your head's at. I'm not going to try it live, but that might be it. Yeah, because then I can do color for the solid interior part, and then, oh, brilliant. See, I love live coding in front of people for this exact reason. I get like 200 extra brains. Excellent, thank you. So just to reiterate the suggestion, I was trying to be perhaps lazy and have my cake and eat it too and say, well, I'm going to use the PCH in R is plot character. So I was going to use one that uses a solid fill and then a circle around it. But by doing that, I have to control that aesthetic with fill. Sorry, this is like deep in the weeds of ggplot. But the suggestion was, okay, well, do 1 point. I can maybe do some of this on the fly. So do it like this with whatever the usual is. And maybe whoever suggested this can come up with the other plot character. So the suggestion was do another geom point, but use a different plot character and don't. Actually, I think what I'll do is don't map the aesthetic. Just say color is black. Don't do any alpha. Does anyone know what plot character I need? It's one number between like 1 and 25. Does anyone know how to figure it out?
21.
Is it 21? I think you're right. Not this. Has anyone else Googled this before? Yeah, I think it's 21. I'm missing a comma. Okay, so there's work to be done there. It's issues, but yeah, that's definitely the path forward. Thank you. Well, I learned something today. Hopefully you did too. I just had a timer go off. So in the interest of time, we're going to take a 10-minute break. We can answer some questions, etc. There's more here, but there's a whole nother plot. There's some interesting stuff here, and I'm going to keep this posted, and I'm going to maybe fill in some details. Quick question, and then we'll break, and then I'll answer individual questions.
It's not you to clock.
Sure, anything.
You had mentioned strike zone, and what is a strike zone?
Mm-hmm.
I'm thinking, okay, you use the strict definition, like, edge to edge, chest, say, but isn't it a different definition, whatever the umpire calls?
Yeah, for that, I'll refer you back to that same chapter. It talks about what is a strike versus a called strike, which I think is kind of what you're getting at.
Have people studied this?
Oh, yeah.
Different umpires,
Yeah.
what their strike zones are?
Has anyone ever seen like umpire report cards? Yeah, so yeah, it's definitely a studied problem. Okay, yeah, so we'll take a break, hang out for a bit, and then Jim will continue.